Hey guys, this is test 58 game 3. This is the plane flights game. It's an ordering game. We know this because they tell us in the first rule that only one plane departs at a time, and they also tell us that some planes depart before other planes. So as such, there must be an order in which these planes depart on their flights. So I've laid out some rules here. I'll explain each of those. They tell us that F is both P and Q. Fly high owns P and Q, and getaway owns R, S, and T, so I've grouped those together here on the side. We also have this whole international versus domestic thing. They tell us that each one is domestic or international, so domestic flights go to, there are certain planes that are domestic, there are certain that are international. They tell us more about those next. P is international, and Q and R are domestic. So when they tell us that in the final two rules, internationals occur before domestics, I put I before D and immediately combined it with the last rule. Getaway domestic happens before fly high domestic. So we have the general ordering. I is before getaway domestic, which is before fly high domestic. Now, since we know that P is international, I made this parallel ordering over here. I is P, R is getaway domestic, and Q is fly high domestic, because they told us earlier Q and R both made domestic flights. And so since Q is from the F group, we know it's after R, which is from the G group, which is after P because P is international. So we have this general ordering, P before R before Q, with P being international, R being domestic, and Q being domestic. Now they tell us that, we've got S and T, we know they're both within the getaway group. So if they're international, they're certainly going to be before both R and Q, and if they're domestic, well then they're going to be before Q. So we can actually say then that S is before Q and T is before Q, even though we don't know whether S and T are domestic or international. They are loosely going before Q. If they're domestic, we know that they're kind of ambiguous with R, and if they are international, then they are definitely before R and ambiguous with P. So this right here is our general setup for the game. Obviously, we'll flesh things out more over the course of the questions. So question number 13 is a typical orientation question. We're just taking one rule or inference at a time and applying that to all 5 choices. Now, we know that Q has to be last. We infer that initially, so A, B, and C can all be eliminated because they do not feature Q last. And we know that, again, Q is domestic fly high, and because S and T are getaway, they're going to be before Q no matter what. Now, we're down to D and E. We know that P is before both R and Q, so we can simply check for violations of that. We see that choice E has P between R and Q, so E is gone, leaving D by elimination for number 13. Next, number 14, how many planes could be the one to go second? Well, we know that R could, we know that S could, we know that T could, and then if P were coming after either T or S, P could be second as well. So any of P, R, S, and T could be second. The only one that could not be second would be Q, because Q comes after both P and R no matter what, whereas P, R, S, and T have a lot more ambiguity, so the answer is 4D for number 14. Next, number 15, if S was before P. So if S is before P, we have the general sequence S, P, R, and Q, and then we have T ambiguously coming before Q anywhere from 1 through 4. So they're asking us what must be false. We can find the 4 choices that must be could be true, eliminate them, and whatever remains is our answer. Or if we see something that simply cannot be true, meaning must be false, then obviously pick it. So could S be first? Yeah, T could be any of 2, 3, or 4, and S could be first. So A could be true and is eliminated. Could S be third? No, S could not be third because we have to have all of P, R, and Q after it. So the latest S could appear would be second if T were first. Otherwise, it'll be first if T is coming after it. So B is impossible and is our answer to 15. I will look at the other choices though. T second could occur if S were the only one before it, so that's gone. T could be third if both S and P were before it and R and Q were after it. And T could be fourth if S, P, and R were all before it. So E's gone, leaving B for number 15. Next, number 16, general must be true question. As we inferred initially, Q has to be last no matter what. Everyone else is coming before it. So for that reason, B is our answer for 16. I will look at the others though. P does not have to be first because any of either T or S could be first, so A is gone. Must R be second? Well, if S and T were both after it, that would be the case, but S and T could also go before it, so S could be 3 or 4 as well, and C is gone. Looking at D, S first, no, either P or T could be first as well, and then T fourth. T could be anywhere from 1 through 4, so it could be 1, 2, or 3 as well, so E is gone, leaving B for number 16. Next, number 17, if S were third. So if S were third, that means that we would have to have exactly 2 things before it, and P and R could go on 1 and 2. We'd have S on 3, and then we could have T on 4 and Q on 5. Or S could be third. We could have T and P before it, interchangeable, T slash P, P slash T, have S on 3. Then we could have Q on 5 and R on 4. So yes, R could be before both S and T, and since this could be true except, we want to find the 4 things that could be true and eliminate them, so for that reason, since A could be true, it's gone. Next, looking at B, S before both Q and T. That could happen in the top diagram right here. S is clearly, as you see, before both Q and T, so B's gone. Looking at C, S before R and before T. Well, here we have S in between R and T, so that wouldn't work. And in the bottom diagram, we have S before R, but after T. So therefore, it's not possible to have S before both R and T, because if you think about it, if S were before both R and T, then we would still need to have Q coming after it, since Q is always last. And as such, the only thing that would be able to go before S would be P, and then S would be second rather than third, as the question stem says. So for that reason, C is impossible, and is our answer to number 17. I will look at D and E though. D says T before P and before S. We could have that in the bottom diagram here, number 2. We could have T on 1, P on 2, and then have S on 3. So D is possible and is eliminated. Looking at E, T before both R and S. That could happen in this diagram as well. We could have T either on 1 or 2. Either way, we have S3, R4. Therefore, E is possible as well and is eliminated, leaving C.